Hello, welcome again, guys, in our subject, reinforced concrete design. And for today's lecture, we will continue our discussion with the economical design of RC beams. And today, focus tayo dun sa known cross-section. So last time, we already discussed how to design the beam if we do not know the dimension of the given beam. Right now, we will now consider designing the beam when the dimensions are given. So our task now is just to identify how many reinforcing steel bars are needed to support the given loading on our beam. Okay, so um, the same as last time, we outline yung mga steps na gagawin natin for this procedure. So number one is to compute yung factored moment natin acting on the beam, meaning we need to calculate MU based from the applied loadings that we have and using the load combinations that will govern for our beam. And next, we will assume that the phi is equals to zero point 0.9, meaning we consider the beam or we assume the beam as tension controlled or it is behaving as fully ductile. And to calculate yung required nominal moment natin, which we will use for our design. Then next, we we calculate the value of rho for design purposes. So this equation is already derived last meeting. Okay, so we have 0.85 f prime c over fy times 1 minus square root of 1 minus 2 rn over 0.85 f prime c, where we considered already na si rn is equivalent sa mu over phi bd squared. Since we let si mu over phi as mn, we have this equation as mn over bd squared. So as we can see, itong Rn value natin in this equation, we can substitute this value. So we will have a formula now, similar formula, uh, 0.85 f prime c fy times 1 minus square root of 1 minus 2 mn over 0.85 f prime c bd squared. Okay, so we can use any of these two formulas to calculate for our rho. And after calculating that, we will proceed on the next step, which is to calculate our required reinforcement or stencil reinforcement using the formula. Right, A is required is equals to rho times B times D. And then after getting the value of the area, if we are given the diameter of rebar, we can easily get the number of rebars required by just dividing the value of the AS required by the area of one bar to know the numbers that we desire. But we can also use the table provided in McCormack's book or the one that I have made, which is catered to the Philippine setting, which is as shown. Okay, so dito we have kung paano basahin to, we have here yung number of bars as this row, and then ito yung bar designation natin. Yung numbers inside means yan yung number ng area. Depende sa nadami ng bakal. So let's say you are trying to provide 3 pieces na 16. Okay? So 3 pieces na 16 diameter rebar is equivalent sa 603 mm squared. Okay? So kung gusto mong kunin siya manually, you just need to get the area of 16 diameter rebar pi over 4 times 16 squared times 3 pieces, and that will arrive or that will yield to 603 as shown on the table. So same condition applies on all of the values stated here. I just made this table for faster calculation ng areas natin so that we can um, make the process shorter. And also we can check yung minimum beam width nung no, na required for each rebar. So paano ba yan? So let's say ito yung biga natin, and let's say you are trying um to to reinforce yung beam mo with 316. Okay, so ang requirement niya is 222 yung minimum width niya. So ang ibig sabihin niya, so halimbawa ito yung tatlong 16 diameter rebar mo, so dapat daw itong width na to is at least 222 para magkasya tong arrangement na to. Okay, and these values are from This figure lang din, no? So we have here yung from the center nung yung nasa edge nating reinforcement going to the concrete cover. Okay? Ah, ito yung CC natin. And this is our diameter ng bar. And then ito yung 0.5 ng diameter ng bar. Another 0.5 ng diameter ng rebar. Then we have here the spacing that we have for each piece ng ating reinforcement, longitudinal reinforcement na stated dito. So, yan. So, spacing. Okay? And this table already calculates that for you para ma-check mo kung halimbawa meron ka lang 300 na bakal, 300 mm na width, and then ito yung if i-support mo, no, 3 pieces na 16, ibig sabihin, kaya, no, kasyang-kasya yung mismong rebar mo. Kasi 222 yung required pero 300 yung gamit mo. So, kasya yung 316 mo. So, it is safe to provide dun sa mismong beam mo. Okay? So, ayan. After nun, you will arrive now with the number of rebars that you want to select as your reinforcement para dun sa beam mo. All we need to do is just check yung mga requirements from the code. Yung NSCP requirements natin, meaning yung kailangan yung ating strain should be greater than to our yield strain. Okay? And also should be greater than sa i-limit natin if we want to control na siya ay tension control. Okay? Kasi, di ba ginamit nating assumption kanina, yung phi natin na multiplier for our moment is 0.9. So, we need to achieve this condition. Kaya kailangan greater than yun yung ating actual limit or actual strain dun sa limit natin. Okay? Once you verify that, next to verify is yung minimum area na required for the beam, AS mean. Na we already know that na BW times T over Fy multiplied by maximum of any of the two quantities, so 0.25 of F prime C or 1.4 megapascal. So whichever governs doon sa dalawa, that will be multiplied dito sa term na to, and that is your AS minimum, which should be satisfied nung na-provide mong AS dito sa number 4. Okay? After verifying that we can check daw yung section efficiency natin. And to check for the efficiency, all you need to do is just calculate yung design strength natin, yung MN. So, efficiency is yung required, or meaning yung nakuha natin sa step 1, required moment. And then yung nasa ilalim natin is yung design moment natin, which is yung capacity ng mismong section natin. So, ano yung pinoprovide nung reinforcing bar natin na capacity, and then we will compare it with our required moment, and ang gusto nating result is as much as possible is greater than 90. Okay, but syempre dapat less than 100. Okay, mas magiging mas economical siya kung greater than 90% makukuha nating efficiency. Pero kung less than naman, okay lang siya, no? As long as masatisfy natin lahat ng checking. Basta dapat hindi siya greater than 100 because it means na hindi kaya ni beam section suportahan yung loading natin kapag nag-exceed siya ng 100. Okay? Ayan. So, to um, to better understand these procedures, we go to an example. Okay? So we have select the reinforcing steel for a 400 mm 575 beam that is subjected with a moment of 220 kilonewton meter, assuming that F prime C is 21 megapascal and Fy is 420 megapascal. So yun yung problem natin. We need to identify or select yung reinforcement for our beam. So our given is we have a beam with this cross section. So this is 400. Okay, and then the height is 575. Okay? So we don't know kung ilan yung concrete cover natin, pero according to sa previous lecture natin, the code specifies a minimum concrete cover para sa mga biga natin depending on the condition. So let's say nasa internal beam naman to, nasa loob ng building, we can use 40 mm or 50 mm depending on our reinforcement. So 40 mm is for diameter 16 or lesser, or si 50 mm is greater than 16 mm. So, pwedeng assume natin na 50 mm na lang. Okay? And then, we have here yung magiging effective depth natin, which is just the total minus yung concrete cover natin, that is 525 mm. Okay? So, yan. So we have our F prime C is equals to 21 megapascal. We also have our Fy, which is 420 megapascal. So for our first step, we need to calculate our factored moment. Fortunately, on this problem, Mu is already given. So we have our first step already done. Okay. Number two, we need to calculate for our Mn using the formula Mu over phi, wherein si phi, we assume that as zero point 0.9, meaning we assume that the beam is tension controlled. Kaya gagamitin natin si zero point 0.9. Ngayon, Mn would be equals to 220 kilonewton meter all over zero point 0.9. So, how much? 220 divided 0.9, that is 244.44 kilonewton meter. Okay? After arriving with that value, we can now calculate the value for phi using the formula 0.85 f prime c over fy times 1 minus square root of 1 minus 2 mn over 0.85 f prime c b d squared. Okay, so just need to substitute the values. 0.85 times 21, we have 420 here, and then 1 minus 2. Then for the moment, we will use 244 pero change natin into Newton mm. Kaya i-multiply natin by 1 million. Okay? 10 to the 6 all over 0.85, 21, 400, and then 525. So, uniformity ng unit yung gusto natin mangyari, no? Kaya, ganyan yung kinonsider natin. So, calculating this value, we have, for a while, so 244.44 times 10 to the 6 all over 0.85 times 21 times 400 times 525 squared. Okay, we will arrive with 0.00566 as our rho. Okay, after calculating that rho, we will calculate now our AS required as equals to P BD, or just substitute that value, 566 times our 400 times our 525, then arriving with our required area of 0.00566 times 400 times 525, that is 1188.6 mm squared. Okay, so this is our required area. Okay, now dun sa problem hindi specified what rebar reinforcement yung gagamitin natin, kung anong size, no? For beams, ang minimum or ang inaalaw ni code is 16 mm dapat yung longitudinal bars natin at least. So, you can select from 16 going to 40 na mga diameter rebars, whichever will be more sufficient dun sa mismong section natin. Okay? So, try natin na yung diameter bar natin is equals to 16 mm. Okay? So, to get the number of rebar, we will divide yung AS required na na-calculate natin by yung AS nung rebar alone. Okay? So, we have 1188.6 divided by pi over 4, 16 squared. Para makuha natin yung required number of bolts. Okay? So, 11886 divided by pi over 4, 16 square. So we have 5.91, or say 6 pieces. Okay, so 6 pieces of 16 mm. So to check whether 6 pieces 16 mm will be enough or papasok dun sa mismong beam natin na 400, we can go back dun sa table natin. Okay, so ito yung table natin. So for yung area muna, ang 16 mm na 16 mm na 6 pieces, okay? Yan, meron siyang, meron siyang area na 1206 which is greater than dun sa required natin which is okay naman ano, 1206. So, okay tayo dun. And then for minimum width, yung 60 natin, 6 pieces, ang minimum width na kailangan daw niya para magkasya yung latag nung 6 pieces ay 345. Eh, 400 yung given beam natin. Therefore, si 616 is pwede, no? Pwede siyang gamitin as our trial, okay? So, meaning dito sa ating problem, we can use 6 na 16 dun sa biga natin, okay? So, may AS na 1206 yung nakalagay dun sa table 1, okay? So, ayan ganyan siya. Pero kung halimbawa nilimit ni problem ano, so this is just, to show you kung paano ulit basahin. Halimbawa pinagamit is diameter 28 na rebar, okay? So, paano mo ngayon ika-calculate? So, kung manually, we can have AS required, same lang din ano, AS required over yung AS bar natin. So, that will be 1188.6 all over pi over 4 times 28 squared, okay? So, ilan yan? 1188.6 pi over 4, 28 squared. So, answer is 1.93 or say 2 pieces. Okay? 2 pieces na rebar. So, pag-check ulit natin yung table. So, si 28, okay, na 2 piece is 1232 yung area niya. So, okay. Pasok naman do sa required natin na 1188. And then, yung requirement for 2 pieces na 28 na width is 196. So, pwede din siya. Ibig sabihin, we can also select si 228 kung halimbawa yun yung required ng problem na 28 diameter rebar lang. Pero kung papapiliin kayo kung ano, kung halimbawa kayo talaga yung designer on which rebar, diameter ng rebar yung gagamitin mo, you can go back dun sa dun sa presyo 'no, kung economy pinag-uusapan, magkano ba ang kakalabasan ng 6 na 16 versus sa dalawang 28 and makikita mo 'yan is dun sa area mo kasi ang presyohan ng bakal is naka-base sa weight sa kilogram per meter or yung ton per ton. So dito makikita mo 1206 yung total area kapag 16 and then dito 1232. So kung parehas naman siyang puwede, alam ko mas mura siyempre si 16 rebar. So much better na si 616 yung gagamitin natin for our section, okay? Pero again, kapag kinokontrol ni problem yung diameter ng rebar, you just need to use yung sinabi sa problem. Pero for our case, we will use itong 616 as our reference rebar. Okay? So, ayan. So now that we have our rebar, we now check yung doon sa minimum requirements natin ni NSCP and yung efficiency natin. Okay? So, this is step 6. Tama ba? 6 na? 4. This is our step 5. So, 6 is checking of NSCP requirement. Okay? So yung ating AS required, AS provided na gagamitin natin ngayon is 616. Okay? Ang area niya is 1206 squared. Okay? This is 6 pieces as diameter 16. Okay? So para makuha ma-check natin yung strain, we need the value of A using the formula ASFY over 0.85 F prime C B. Okay, so we have 1206 times 420 all over 0.85 times 21 times our width, which is 400. So value of A is 1206 times 420 over 0.85 times 21 times 400. That is 70.94. So we can store that dun sa letter A ng calculate natin. Okay, next is for our C. C is equals to A over beta 1. Pero since reinforced uh, our concrete strength is 21 megapascal, our beta 1 will be equals to 0.85 lang. Okay? So C is equals to 70.94 divide 0.85. We have 83.46. Okay? So that is in ano, same with A. So let's store that sa letter B. Okay? Then to calculate for the strain, we have 0.003 D minus C over C. So just substitute yung mga required values. 0.003 times 525 minus our value for C over value ni C. Then we have 0.0159 as our strain. Okay? Our actual strain is equals to Fy over ES or 420 over 200,000. So that is 2.0021, but the code says na kapag 420 megapascal, we can use 0.002 as our yield strain. Okay? And for our limit strain, we have our yield strain plus 0.003. So we have 0.005. Okay? Since our strain sa steel is greater than dun sa yield strain natin, therefore, yung steel natin is nag-yield. Okay? Therefore, tama yung assumption natin na Fy natin is equals dun sa ultimate stress niya. Okay? Then, we have ET is also greater than dun sa limit natin. Therefore, siya ay tension controlled. So, kung tension controlled siya, tama yung assumption natin na ang phi natin ay equals to 0.9. Okay? So, check na tayo sa checking ng strain. Next checking is for AS required or minimum, AS minimum using the formula BW times D over Fy times maximum of 0.25 of square root of F prime C over 1.4. Okay? So, we have 400 times 525 all over 420. And then, whichever is maximum. So, 0.25 ng square root of 21, ang value niyan is 1.146 and then si 1.4. So, alin ang mas maximum? Si 1.4. So, si 1.4 yung i-multiply natin on this expression. So, yung ASME natin is equals to 400 times 525 all over 420 times 1.4. So that is 700 mm squared, which is less than rather, dun sa ating AS provided. Therefore, okay. So, ibig sabihin yung requirement for AS minimum is satisfied already. Okay? So, kung yan na yung case, okay na yung NSCP checking requirement natin. Ang next step is to calculate for our efficiency. Okay? Again, the formula is yung required moment natin over yung design moment natin. Okay? For design moment, we can calculate that as ASFY D minus A over 2. So we have 1206 times 420 times 525 minus yung A value natin, that is 70.94 over 2. Okay? So yung MN natin is equals to 1206 times 420 times 525 minus 70. Yung store value natin sa A na lang over 2. That is a very large number. Divide natin by 1 million. That is 247.956 kilonewton meter. But we need is VMN, yung design capacity natin, which is 0.9 times 247.956. That is equals to 223.161 kilonewton meter. Okay? So, yung efficiency natin now will be equal sa mu over VMN. So that is yung mu natin from the first step is 220. Okay? So use 220 kilonewton meter divided by our 223.161 kilonewton meter times 100. So that is 220 by 223.161 times 100. So that is 98.58%. Okay, yung efficiency natin. So, yung value ng efficiency natin is very good ano kasi 90% hanggang before mag 100 is a very good design value na kasi economical na ibig sabihin yung selection natin. So, kung magiging less than 90, okay lang din naman as long as satisfied yung checking natin. Pero if we have the choice to determine kung ano yung magiging mas efficient na section natin and kung saan mas makakatipid si client, yun yung susundin natin. So you can manipulate yung mga diameter ng rebars, okay? Or kung ano man yung pwede natin galawin, kung halimbawa hindi naman stricted ni architect yung dimension natin, we can change the dimension of our beams para mas maging efficient siya and mas economical for the side ng ating client. Okay? So, once na nasatisfy natin na efficient yung section natin, we conclude na use 6 pieces ng diameter 16 mm longitudinal rebars. Okay, so this will be our final answer for this problem. Okay, so yan. So ganyan lang yung pag-design ng ng reinforcement kapag given yung dimension, which is more straightforward rather than dun sa unknown cross section. Kasi pag unknown yung cross section, we are the one entitled to decide what will be our dimension ng beam natin. Okay? Kung wala namang limitation si architect. So, as long as ma-check natin or ma-satisfy natin lahat ng NSAP requirements and itong efficiency requirement natin, then our beam will be useful or can be used as the design beam for our cross section. Okay? So, next time, we will discuss yung design ng one-way slab and the treatment is hindi masyado naglalayo dun sa beam natin. Okay? So, thank you for watching and goodbye for now.